Okay, so we're going to work on order of operations, and when we go through this, we're going to quickly go over a few of the fraction rules. Well, this one we don't have fractions, but we'll go over some integer rules, okay? Now, quickly, just to make sure you guys remember this, positive times a positive number. Does anyone know what your answer will be? Positive. Good. Negative times a negative number? Good. And then when they're not the same operation, that's right, we have a negative times a positive or vice versa, and we'll get a negative. Excellent. Now, according to order of operations, we usually refer to it as BEDMAS. Right? What is the first thing we would deal with according to BEDMAS? Okay, do I have brackets? Yeah, technically I do have a bracket. A bracket is around a negative number, but is there any way I can simplify this? Okay, but we do got to look at our order of operations here. The bracket only has one term inside, so there's nothing to do with it. We can't really simplify a number. There has to be something in the bracket with it. So there's nothing to simplify in terms of brackets. The second thing we'd be dealing with is what? Exponents. Do I have any exponents in this question? No. Now, side note, technically all of these are to a exponent. Do anyone know what it is? Yeah, technically there's a little 1 on all of these, but we don't need to write it in, all right? Because the 1 isn't going to change anything. So we'll make sure that disappears. Okay, after that, we have division and multiplication. They technically go together in what order? Left to right, right? Just the way we read. So depending on how they show up on our page. Now, do I have division or multiplication here? What do I have? Multiplication. So I actually wouldn't deal with the 11 plus minus 3 first. I would actually deal with the negative 3 times the positive. If there's no number there, we assume it's a positive number. So we go with that first. It is a negative times a positive. So what is it? Negative 3 times positive 3? Negative 9. Excellent. That makes it very simple for us. All right? From there, we just have 11, subtract 9. What are we going to get? 3.
2.
Oh, sorry. Yeah, you're right. Who said 3? Remind me not to listen to you. 2. Okay. Second example here. We're dealing with a whole number and 2 fractions. Even though we're with fractions, it doesn't mean we deal with them first. We still do everything according to BEDMAS. Any brackets? Any exponents?
No.
Any division or multiplication? Yes. Okay. I have 1 times 1/2. Now, in order to do my multiplication with fractions, okay, what we do, so here's just a quick example. Let's say we had 2 over 5 times 1 over 2. When we multiply fractions, we multiply the numerators by each other, so the numbers on top, and the denominators by each other, so numbers on the bottom. So 2 times 1 would give me 2. 5 times 2 would give me 10. Okay? When you guys write your quiz, I'm going to want you to put it in lowest form. Can I reduce that fraction?
Yeah.
What does it become? Good. Excellent. Thanks, Jeremy. All right, but in our question here, I have a whole number and a fraction. How can I turn this whole number into a fraction? Over 1. Any whole number can be turned into a fraction by just putting it above the number 1. Anyone know why? Because you're dividing by 1, right? That fraction, that line in between means divided by. So let's just choose any random number here. Let's say we had 5 divided by 1. We would still get the number 5. So it doesn't change the number at all. But what it does is it helps us simplify when we're going to multiply these numbers. So we go to simplify this, we do the top by the bottom, or top by the top, and then the bottom by the bottom, so we get 1 by 1 and 1 by 2. We still have a half. Makes sense, 1 times a half, 1 doesn't change anything. But in the second part of this, we're now subtracting a fraction. In order to add or subtract fractions, so let's say I had that same question again, 5 over 2, subtract 1 over 2. What do I have to get the same in these? Denominator. So I got to find a common multiple, it's called. And it just so happens we're using 5 and 2. I should use a different example. But what would be a common multiple? 10, right. So we want both of our fractions to be above the number 10. In the first fraction, how do I turn the denominator into 10? Yeah. And do I only multiply the bottom? No. Whatever we do to the bottom, we got to do to the top. So on top, we'd have 2 by 2. We have 4. What do I multiply the other fraction by? Excellent. What do we got? Okay. Now when subtracting, do we do the top by the top or bottom by the bottom? Yes. We're still going to end up with the exact same denominator. Make sure you remember that. When you add or subtract fractions, the denominator stays the exact same once you've got them the same. This becomes 4, subtract 5. What's that? -1. So we have a negative value here in this example. So let's do the same thing over here with this question. I know they're the same things. This is going to be 5 over 10. And in this one, we got to multiply by 2. Well, 7 times 2 is going to be 14. So we get 14 over 10. Our answer is still going to have the exact same denominator of 10. 5 subtract 14. Okay, good. We're going to have -9. Now, does that mean only the 9's negative? Or is the 10 negative? Or is the whole thing negative? The whole thing is negative. And the reason the whole thing is negative, I want you to think of it like this when we're doing integers. This is a negative divided by a positive. Those rules are identical. Oh, can I scroll up here? Those rules are identical to our multiplication of integers, okay? So, whether we put the subtraction on top, this is a negative divided by a positive, or I decide to write the question as 9 over -10, that's still a positive divided by a negative. When we actually simplify this, we'll still have a negative answer. So anytime you see a negative with a fraction, think of the whole number altogether being a negative. Okay? Okay, third example we're going through. We already memorized BEDMAS, hopefully. Brackets, I look at it, there's nothing I can simplify. We don't have any exponents. So division and multiplication. I have 2 division signs. So what pairing do I work with first? Not the bracket, because it's not inside the bracket. I deal with the very first 2 terms, just like we read, left to right. Okay? So if division and multiplication are in the question, it's whatever comes up first when going left to right. So we're going to deal with 9 divided by 4. Now, dividing fractions. Many of you guys may not remember this rule. Let's say I had a question like 1 over 5 divided by 2 over 3. We turn a division of a fraction question into a multiplication question. So the first term stays the same, 1 over 5. The division now becomes multiplication, and we invert the fraction. So we get 3 over 2. And then, remember the rules for multiplying fractions, top by top, bottom by bottom, 3 over 10. That would be the answer. So we always invert it. So, very first thing I need to do in this question, I have a whole number. How do I make 4 a fraction? 4 over 1. Okay. So we're going to do that exact same process. We still have 9 over 5. I then turn it into a multiplication question, and we invert this fraction. So it then becomes 1 over 4. Okay. Deal with that first, and then we'll divide by -3. Multiplying fractions, we get 9 over 20. I'm still dividing by -3. So right off the bat, I have a positive term divided by a negative term. What's my answer going to be? We know we're going to have a negative answer, so let's keep that in mind. I'm going to turn 3 into a fraction again, since the first term is a fraction. This will become -3 over 1. Oh, I want the page width. That's better. We still have 9 over 20. This time we change it to multiplication again, and it becomes -1 over 3. Okay. Again, it doesn't matter if I apply the negative to the top or the bottom. Let's just think of it as the whole answer is a negative. And then we're just going to go 9 times 1 is 9, and 3 times 20 is 60. Can I reduce this? What can I turn it into? 3 over 30. What else? Or is it 3 over 20? Good. There you go. Excellent. And that would be our final answer for 1. Okay. We have an exponent question which you guys wanted me to deal with. That's okay. We have 8 divided by -2. Okay? They're 2 whole numbers, so really all I have to do is turn it into a fraction. We have 8 divided by, because that's a negative, the whole thing becomes negative. 8 divided by -2. So now I'm only working with a fraction to the power of 2. Anything that's an exponent is just repeating the base twice. So we get negative 8 over 2 times negative 8 over 2. So we've used the exponent, and then this is just multiplying fractions. We can put the 8 or the negatives on top together, on the bottom, or separate. It doesn't matter because the negative times the negative is going to give us what? Right? So our answer is going to be positive. I go across the top. 8 by 8 is 64. 2 by 2 is 4. And we can reduce that to, what, 32 over 2? 16? 16. Perfect. And that's that.